price-taking company's short-run supply function is given to us by the marginal cost curve from the intersection with the average variable cost. So let's prove that. We have the modular cost function, which is defined as the change in total variable cost when you change the quantity, and that is U-shaped in this case. We have the average variable cost, which is downward sloping until it intersects with the modular cost. To get an average to go down, we must add the modular that is lower than the average prior to the next unit. So as long as modular cost is below average cost will have a negative slope, and vice versa. And that is of course true even for the average cost, the total average cost, where you have both the variable cost and the fixed cost. So we're selling this to a market, and we are price takers. Otherwise, we shouldn't have a supply function. It's just price-taking companies that will have supply functions. So if we're facing a market price of P2, that will give us the marginal revenue for each unit, because we know that we're going to sell them for the market price each unit. So therefore, the marginal revenue, the revenue per unit for the next unit, will always be equal to the market price. So we'll have there that the change in total revenues when we change quantity will be equal to the marginal revenue too, like this. And the normal assumption, or the condition, the normal condition for profit maximizing is that the last unit you sell should have a revenue that is equal to its cost, marginal cost. And we see that this is fulfilled in two positions, up down there with a very small number of units, and up here. And when we look at this position, we see that the marginal cost is intersecting with the marginal revenue from above. And that means that each unit up to this one has had a marginal cost that is higher than its revenue. So this is the kind of loss maximum, not the profit maximum, it's a loss maximum. So when we continue along the marginal cost function, we see there that the distance between the revenue and the cost per unit, which is increasing and then decreasing a little bit. So all of this will be sold with the marginal profit. So we add profits per unit here. So therefore, this is the profit maximizing quantity where the marginal revenue is equal to the marginal cost. So that gives us a quantity of Q2. What's the profit here then? Well, we know it's the maximum profit we can receive. We can't get any higher. So let's calculate it. Profit is defined as total revenues, that's price times quantity, minus total cost, which in this case is calculated out from the average cost function. So we have price times quantity minus quantity times the average cost for the given quantity. So times price times quantity, that's P2 times Q2, that's this rectangular here, and quantity times the average cost for the given quantity. There's the average cost, there's the quantity, so that will become that rectangular, which is identical to the first one. And we see here that P2 times Q2 minus Q2 times the average cost for Q2. So we can take out the parentheses here and let Q2 be outside. So we have Q2 times P2 minus this average cost at Q2. So this is the average profit per unit times the quantity that we are producing. So if the price is equal to the average cost, we have a 0 inside the parentheses here. So 0 times Q2 is always equal to 0. So the total profit will be 0 in this situation. So if we increase the price to P3, we will receive a higher marginal revenue 3. And the same reasoning, we're going to look for the marginal cost equal to marginal revenue. So we see that we're going to produce at this position. And therefore, we're going to produce Q3 units. So let's calculate the profit. We have P3 times Q3. That's this big rectangular over there. And then we have the average cost times Q3. So we have a little bit smaller rectangular down here. And now it's the time to use this parenthesis we have down here. Instead of P2 and AC at Q2, we have P3 up there. And we have the average cost for Q3, which is down there. So we see that we have here a positive difference between the price and the average cost. So if we are producing and selling Q3 units at the price of P3, we will actually receive a profit that is greater than 0. Okay. So if we go the other way and go from P2 down to P1, we will receive marginal revenue 1. Same reasoning, we will have a profit maximizing quantity at Q1 here. We can calculate the profit, P1 times Q1, minus average cost time at Q1 times Q1, that's that large. So we see that it's a negative difference between average cost and price at this quantity. So we will have a loss. And since this is the difference, the vertical difference between the average cost curve and the average variable cost curve at Q1 is identical with the average fixed cost for Q1 units, that indicates that the loss, the negative profit that this company will achieve is equal to the fixed costs. And that is the largest loss that any company is willing to achieve, to have. Because if we reduce the price even further, we will have a profit maximization quantity down there, and that indicates that we don't even cover our variable costs. And if we don't cover our variable cost and the fixed cost, we will have a greater loss staying on the market than if we left the market. If we left the market after had the price P0, then we will have a loss of the fixed cost and nothing more. But if you stayed on the market for P0, we will have a fixed cost plus part of the variable cost as loss. So therefore, the intersection between marginal revenue 1, marginal cost, and average variable cost, this point here, is called the shutdown point, because this is the lowest price that this company in this situation is willing to accept. And that indicates, of course, that the supply function will be equal to the marginal cost curve from this position, from the shutdown point and upwards. So it's the marginal cost function due to the marginal, the condition for profit maximization, that marginal revenue should be equal to marginal cost. And it's from the shutdown point, the average variable costs minimum, due to the result, the profit, the negative or positive profit that we actually receive from selling this product.